Imagine sitting on a park bench next to someone who has been completely blind since birth. You decide to describe the surroundings, trying to explain the warmth of an orange sunset and the shape of the clouds. When you ask them what image is forming in their mind, their answer is nothing. They don't see a black screen or an empty void. They experience total sensory nothingness. Even among those of us with sight, reality fractures. 1 in 12 people has some form of color blindness, meaning the exact same light waves generate a different visual world inside their brain. If lacking one biological sensor erases an entire dimension of the physical world, the space around us and the ticking clock we feel may be an elaborate biological illusion. For thousands of years, the debate over what the cosmic backdrop actually is has split the world into two distinct camps. In the 17th century, Isaac Newton and René Descartes popularized a concept called absolutism. They argued that space is a rigid, three-dimensional box, and time is a strict, unyielding clock that ticks at the same speed for everyone. A German mathematician named Gottfried Leibniz disagreed. He proposed relationalism, arguing that space and time vary between observers. Leibniz believed that particles contain intrinsic properties, like positive or negative charges. As these particles attract and repel each other, their interactions create what we perceive as distance. Without those objects interacting, the box of space vanishes. This theoretical divide between a universe that acts as a physical container and one that exists only as a network of relationships triggered the most difficult structural crisis in modern physics. By the early 20th century, mathematical models allowed us to look far beyond Earth, studying the mechanics of the universe at a macro scale. That is when Albert Einstein dismantled Newton's rigid box. He proved that space and time cannot be separated. They are a single, interwoven entity. This space-time fabric is flexible. It stretches, compresses, and warps, depending on how fast you move and the gravitational pull acting upon you. This introduces the problem of time. Because space-time is a single bound structure, the past, present, and future exist simultaneously. The sensation of time moving forward is just biology. Your brain acts as a mental clock, processing a static universe frame by frame. If time does not flow and space warps, our physical reality is far less stable than our brains allow us to believe. If you leave the massive scales of stars and planets and plunge into the microscopic floor of the universe, the geometry of reality changes. Modern physics is currently stuck on a direct contradiction. Einstein's math requires the fabric of space-time to be perfectly smooth, but quantum mechanics shows that at the lowest level, reality is composed of discrete, pixel-like chunks. Emergence theory bridges these ideas. It suggests our 3D reality is an asymmetrical projection, a shadow cast by a higher-dimensional 8D crystal. At the Planck length, this structure is built out of fundamental 3D units shaped like tetrahedrons. If the universe is built out of these disconnected, microscopic geometric pixels, something must hold them together to create the physical distances we see. That connection is quantum entanglement. It allows particles to instantly share information without traversing physical space. Physical space arises as the emergent byproduct of billions of these quantum relationships processing data. To translate all of this raw quantum data into a physical shape, the system requires one final component, an active observer. Before it is measured, quantum data exists in superposition. This is a state where a particle's exact location and momentum remain undecided, existing as a blurry cloud of probability. This behavior is a proven fact of nature. The experiments confirming that particles remain undecided and entangled until they are measured earned the 2022 Nobel Prize in Physics. When we observe these particles, the blurry superposition collapses into defined properties. Emergence theory suggests that the act of observation, the interaction with a conscious mind, is what forces this raw information to resolve into a specific physical reality. Under this framework, the universe functions as a stream of geometric information. physical space and time become the interface our minds use to render that code into a world we can navigate.